Hello everyone. In this video, we are going to talk about infinity limits. So what is this? First of all, when we look at a function which is defined on both sides of some number a, maybe not exactly at the number a, but it's defined on both sides of the number a. Now, if we look at the limit, the output values of the function f, when x gets closer to a, if the output values are getting larger and larger or arbitrarily positively large, we write limit of f as x goes to a is equal to positive infinity. Okay, so visually it looks like this. So when we get closer and closer to a, as you see, the output values of the function are getting larger and larger positively. So we just write limit of this function as x approaches to a is positive infinity. Okay, so this is called an infinity limit. So the output values are getting larger and larger, larger and larger. They don't stop at a finite number. So then we express this phenomena in this way. We write the limit of the function gets positively arbitrarily large. Instead of saying positively arbitrarily large output values, we just write positive infinity. Okay, so that's a notation. So positive infinity or negative infinity is not a number. It's just a phenomena saying that some quantity is getting arbitrarily large, positively or negatively. Of course, it can depend on the sign, but there is no finite number. It's just getting bigger and bigger, either positively or negatively. And in a similar way, we write the limit of a function f as x approaches to a is minus infinity if the output values of f uh, they are getting arbitrarily positively larger and larger. Okay, so but negatively larger and larger. So if we see this in a pictorial way, it's gonna look like this. So as you see, when we get closer and closer to a, if the x inputs are getting closer and closer to a, you see that the graph of the function is getting negatively larger and larger. So we write x goes to a, the limit of the function is minus infinity. Again, infinity plus or minus is not a number. Okay, here you should say this as a remark. Plus infinity or minus infinity is not a number because numbers are finite quantities. Okay, but infinity is not. However, we still try to express that kind of situation in this way. Okay, so if we don't stop at a finite number, we then write either plus infinity or minus infinity depending on the situation. So here are some examples. Let's say find the limit of find the limit of x goes to 1 of the function 1 over x minus, well, let's say 2, not too many ones around. So let's say x goes to 2, 1 over x minus 2 squared. So if you look at the graph of this function, I mean, if you sketch this function, you will see something like this. Let's say this is y-axis, this is x-axis, and at 2, what will happen is this. You are going to see something like this. Okay, it's going to get positively and positively larger. Now, how do I know this? We can try. Let's say choose some numbers close to 2. Let's say x equals 2.1, something close to 2. And then put it into the function 1 over 2.1 minus 2 squared. This is going to be 1 over 0.1 squared, and this is actually 1 over 0.01 or 100. Well, choose something closer, let's say 2.001, and then plug it into the function. 1 over 2.001 minus 2 squared will be 1 over 0.001 squared, which is equal to 1 over 0.0, like there is 3 digits after the point, so 1, 2, 3, 4, 5, 6. Well, if you divide 1 by this number, you are going to get 100,000. As you see, we are getting closer and the values are getting arbitrarily large. I mean, I can choose closer numbers, let's say 2.0000001, and then plug it into the function, and then it's going to give me a larger number. So that means I'm going to get something like this. Of course, you can try closer numbers from the left, let's say 1. Yeah, 999. And then what's going to happen? 1 over 1.999 minus 2 squared. This is going to be minus 0.001 squared. And again, it's going to give that same number, 100,000. And you can make it closer. Let's say x equals 1.99999, and then you can try this number, and you are gonna get something like 5 digits, right? So it's gonna be 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I'm not wrong, it's gonna be like this. As you see, there is gonna be like the numbers when we are getting closer and closer to 2, like here is 2, here is, let's say, 1.999, and then here is 1.99999. Like we are getting closer to 2, or we can get closer to 2 from the other side, like 2.001. As you see, each of them getting closer, the values of the function are getting larger and larger. So we see something like this. And another example, let's say find. So okay, what is the result? So we say the limit x goes to 2 of 1 over x minus 2 squared is, since it's getting positively arbitrarily large, we say positive infinity. Another example, find the limit of x goes to, let's say, 3 of 1 over, well, let's say minus 1 over x minus 3 squared. Now this time it's going to give negatively large numbers. You can try numbers, okay? I leave that to you. You should maybe do this. But you are going to see something like this. I'm just going to sketch the graph of what's going to happen. So this time, let's say if this is equal to 3, well, it's going to give larger and larger numbers, but because of the minus here, okay, it's going to give negatively larger and larger numbers, larger and larger outputs. Okay, so the graph is going to look like this. By the way, okay, my graph isn't that careful, so let me fix that. But okay, it's going to look like this. I know how the graph looks like, so I wanted to change it. But anyway, it's going to look like this. It's going to minus infinity. It's never going to stop because you can get closer and closer to 3, and you will see that this will go to more and more negatively large. So you're going to say minus infinity. Okay. Well, there is one more definition here I want to mention. We can have also like one-sided infinity limits. Like we can have one-sided infinity limits. Like one side can be infinity, but the other side can be something finite. Well, let's just consider all of these cases. So let's say if we have some graph like this, let's say this is a, and let's say this is plus infinity, this is minus infinity, but the graph looks like this, then this is the case where we say limit of f as x goes to a from which side? From the right side. So we say a plus, something bigger than a. I mean, x is bigger than a little bit, but the closer it gets, function is getting more and more positively large values. Or you can have something like this. Let's say this is a. Okay, let's say you are approaching to a from the right again, but this time the values are getting more and more negatively large. So you say the right limit of f when x goes to a is minus infinity. Okay. Of course, you can also have left limits like these cases. Let's say this is a, this is f. So in this case, the left limit as x goes to a of the function f is plus infinity, or you can have the other possibility. So let's say you are approaching to a from the left, but the values are getting more and more negative arbitrarily large. So you say the limit, the left hand limit of f is minus infinity. Okay. Now each of these cases are possibilities. Sometimes you can have also like these cases, like let's say this is a, like the first example, or you can have something like this. Well, when we approach to a, the function goes to negative infinity, so we say this. But sometimes you can have crazy kind of situations like these. Like let's say this one, like it goes to plus infinity on one side and then it goes to minus infinity on the other side. Okay, so you may have different infinities from each side. So we can also write this thing like from the left it's plus infinity, from the right it's minus infinity. Or you can have the vice versa situation. Let's say from the left it can be going to minus infinity, from the right it can be going to plus infinity. So you can say then from the left it's minus infinity, from the right it's plus infinity. Also you can have some crazy situations like something like this. This is also possible. Let's say the function goes like this until a, and then it can go like this. Okay, so you can have something like this too, or you can have something like this, and then the function can be going like this. Okay, these are also possibilities. But anyway, we here write the limit from the right of the function is minus infinity. In this one, we write x goes to a, from the left is plus infinity. Anyway, here are more examples. Let's say find limit x goes to 0 from the left and from the right of, or it's, yeah, 1 over x. and also from the right. Well, all we need to do is remembering the graph of this function. Remember, we had sketched these functions before. And how do they look like? They look like this. This is 0. As you see, this is minus infinity direction, this is plus infinity direction. So we can say the left limit is equal to minus infinity, the right limit is plus infinity. Okay, another example, let's say find the limit as x goes to 0 from the right of ln of x. Now, for this one, let's remember the graph of the natural log function. Remember, natural log function has a graph like this. And as you know, as x approaches to 0, the graph goes to minus infinity. So this is equal to minus infinity. And you know, from the left, it's not defined at all. But from the right of 0, it is defined. And the closer we get to 0, ln will give you more and more negative, bigger and bigger negative numbers. So then we say that this is minus infinity. Okay, one more definition. These things are called vertical asymptotes. So this is the definition of vertical asymptote. So the line x equals a is called, like all these previous examples. In my last example, x equals 0. In my, the 1 over x example, also x equals 0. ln function example, also x equals 0. These are vertical asymptotes. Okay, so the line x equals a is called a vertical asymptote of f if at least one of those things happen. If at least one of the following is true. So what are these things? We can have the limit as x goes to a is plus infinity or minus infinity. So this is the case like this. X equals a vertical asymptote. Here, this case is, let's say a is here this time, but both directions are going to minus infinity. Okay, and other cases, I'm not going to draw them because I have drawn already some of them. From the left or right, if you get one of the infinities, or you can have from the right also one of the infinities, then that x equals a line is called a vertical asymptote. Okay, yeah. Just another example. Let's say find limit x goes to 4 from the left of 5x over x minus 4 and find the vertical asymptote. Find the vertical asymptote. So if you sketch the graph of this function around 4 at least, well, from the left, if you give values, you are going to get positively very large numbers. Wait, is it true? No, from the left, we are going to get negatively very large numbers. So it's going to look like this. from the left. Okay, from the right, it's going to look like this, by the way. So this is minus infinity. Well, from the right also we can say it's plus infinity. And then what can we say also? This x equals 4 line is a vertical asymptote. Okay, so you can do many more other examples, and this is what we are going to say about infinities. Now the next video will be about the limits at infinity, but okay, that's going to be the next video.